Special products of polynomials. In our previous videos, we have covered multiplication and division of polynomials. Now let's look into special products of polynomials. They are called special products because the products can be obtained quicker than going through the usual method with the help of formulas. Let's start with the square of a binomial. Square of a binomial. A plus b is a binomial with two terms, a and b. The square of this binomial will be a plus b the whole square. If we use our conventional method of finding the solution of this binomial, we do something like this. A plus b whole square equals a plus b times a plus b. Now we can multiply each term with the first binomial, which is a plus b, with the second binomial, which is also a plus b. So this can be written as a times a plus b plus b times a plus b. As shown with the help of the arrows, this equals a times a plus a times b plus b times a plus b times b, which equals a square plus ab plus ab plus b square, which equals a square plus 2ab plus b square. So a plus b the whole square equals a square plus 2ab plus b square. What about a minus b the whole square? Is that a special product too? Yes, it is. We'll take a look. We can use our conventional method of finding the solution here too and deduce the formula. A minus b whole square equals a minus b times a minus b. Now we can multiply each term with the first binomial, which is a minus b, with the second binomial, which is also a minus b. So this equals a times a minus b minus b times a minus b. As shown with the help of the arrows, this equals a times a plus a times negative b plus negative b times a plus negative b times negative b, which equals a square minus ab minus ab plus b square, which equals a square minus 2ab plus b square. So a minus b the whole square equals a square minus 2ab plus b square. Remember, when we say a plus b the whole square or a minus b the whole square, any term can be substituted for a and b and the formula will apply. Let's look at some examples. Compute 4x plus 3y the whole square. In this case, we use the formula a plus b the whole square equals a square plus 2ab plus b square. Here, a equals 4x and b equals 3y. 4x plus 3y the whole square equals 4x the whole square plus 2 times 4x times 3y plus 3y the whole square, which equals 16x square plus 24xy plus 9y square. Let's look at another example. Find the product of negative 3x squared plus y cubed times negative 3x squared plus y cubed. Solution. Negative 3x squared plus y cubed times negative 3x squared plus y cubed equals negative 3x squared plus y cubed the whole square. Again, we use the formula a plus b the whole square equals a square plus 2ab plus b square. Here, a equals negative 3x squared and b equals y cubed. So, negative 3x squared plus y cubed the whole square equals negative 3x squared the whole square plus 2 times negative 3x squared times y cubed plus y cubed the whole square, which equals 9x power 4 minus 6x squared y cubed plus y power 6. Let's look at the next example. Find the product of 5p minus q times 5p minus q. Solution. 5p minus q times 5p minus q equals 5p minus q the whole square. Here there is a minus sign between the two terms of the binomial. So we use the formula a minus b the whole square equals a square minus 2ab plus b square. Here, a equals 5p and b equals q. 5p minus q the whole square equals 5p the whole square minus 2 times 5p times q plus q square, which equals 25p square minus 10pq plus q square. Let's do some examples with fractions. Find the square of 3m plus 1 over n. Solution. In this case, we use the formula a plus b the whole square equals a square plus 2ab plus b square. Here, a equals 3m and b equals 1 over n. So 3m plus 1 over n the whole square equals 3m the whole square plus 2 times 3m times 1 over n plus 1 over n the whole square, which equals 9m square plus 6 times m over n plus 1 over n square. Let's look at another example. If p squared plus 1 over p squared equals 27, find the value of p minus 1 over p. Solution. It may not be readily apparent how to go about this. When you see the given value, namely p squared and 1 over p squared, which are both perfect squares of p and 1 over p, you should know this has something to do with special product and its formula. Okay, here we need to find the value of p minus 1 over p. Use a minus b the whole square formula where a equals p and b equals 1 over p. P minus 1 over p the whole square equals p squared minus 2 times p times 1 over p plus 1 over p the whole square. Simplifying, we get p squared minus 2 plus 1 over p squared. Let's call this as equation 1. But we know p squared plus 1 over p squared equals 27, which is given. Substituting this value in equation 1, we get p minus 1 over p the whole square equals 27 minus 2, which equals 25. So p minus 1 over p equals square root of 25, which equals 5. Let's do one more example. Find the value of 100.7 squared. Solution. Here, 100.7 can be written as 100 plus 0.7. So 100.7 squared equals 100 plus 0.7 the whole square, which equals 100 squared plus 2 times 100 times 0.7 plus 0.7 squared, which equals 10,000 plus 140 plus 0.49, which equals 10,140.49. Let's look at another special product of two binomials. Find the product of a plus b with a minus b. We'll find the product using the conventional method of binomial multiplication, a plus b times a minus b. Now we can multiply each term of the first binomial, which is a plus b, with the second binomial, which is a minus b. So this equals a times a minus b plus b times a minus b. As shown with the help of the arrows, this equals a times a plus a times negative b plus b times a plus b times negative b, which equals a squared minus ab plus ab minus b squared. Simplifying, we get a squared minus b squared. So a plus b times a minus b equals a squared minus b squared. Let's look at an example. Compute the value of 1 over 3p minus 2q times 1 over 3p plus 2q. Solution. Here the binomials are of the form a minus b times a plus b. Please ignore which order the two binomials are written, since the product will still be a squared minus b squared. Here, a equals 1 over 3p and b equals 2q. So 1 over 3p minus 2q times 1 over 3p plus 2q equals 1 over 3p the whole square minus 2q the whole square, which equals 1 over 9p square minus 4q square. Let's do another example. Find the value of 83 squared minus 17 squared. Solution. Well, this is an interesting example because we are asked to find the value of the difference between two square terms. We can use the special product we just learned in a reverse way. If a plus b times a minus b equals a square minus b square, then a square minus b square equals a plus b times a minus b. Here, a equals 83 and b equals 17. So 83 squared minus 17 squared equals 83 plus 17 times 83 minus 17, which equals 100 times 66, which equals 6,600. Let's do one last example. If 12m equals 42 squared minus 30 squared, find the value of m. Solution. Again, using the a plus b times a minus b formula in the reverse way, a squared minus b squared equals a plus b times a minus b. Here a equals 42 and b equals 30. So 42 squared minus 30 squared equals 42 plus 30 times 42 minus 30, which equals 72 times 12. So 12m equals 72 times 12. Dividing both sides by 12, we get 12m over 12 equals 72 times 12 over 12. Simplifying, we get m equals 72. That's all we have on the special products of polynomials. Thanks for watching.